equations. Essentially, we're doing the exact same thing that we were doing on Friday, except we got one more step, of course. If you recall from Friday, I told you that we were going to be doing reverse order of operations. So if order of operations typically goes grouping symbols, exponents, multiplication and division, then addition and subtraction, we're going to be doing those in backwards order. Now, this isn't always going to be like I do every single step of addition and subtraction first. Sometimes it's tricky, so we're going to keep an eye out for those tricky ones. But in general, what we are doing is step number 1, undo addition and subtraction. Remember, addition and subtraction are inverses of each other, so if it's minus 2, we got to add 2 to both sides. Then after that, we're going to be undoing multiplication and division. And again, we are working backwards here. If you remember from, I'm going to just quickly flip back to last Friday's notes. But I had this little note in here that says, we work away from the variable first and then towards it. So that's reminding me that I'm probably going to have to do the stuff that is further away from wherever my variable is first. Hello, where are we? Okay, so let's look here. In letter A, here is my variable x. And I'm going to draw a line through the middle like I usually do. Now I know based on backwards GEMDAS that addition and subtraction is going to come first. I can also look at this and see, okay, negative 2 is right up against that x, whereas minus 11 is a little bit further away. So I'm working from the outside into that variable. So the first thing I'm going to do is add 11, and remember I'm going to do it to both sides. That leaves me with a negative 2x on the left, and on the right, a 14. And now this just looks exactly like what we were doing on Friday. I'm going to finish it off with my last step, which is to do the opposite of multiply by negative 2, aka divide by negative 2. I should be left with x equals negative 7. Any questions on that? Okay, letter B, same deal. I'm going to draw my line through the middle. I see where my variable is, t, up in the top here. And I'm working from the furthest thing away from the t. Well, the 2 is really close to this t, so I don't want to go there. I'm going to go with the addition and subtraction that's all the way over here. So to undo a minus 3, I'm going to add 3 to both sides to get 8 equals t over 2. And again, now we're at that one-step equation like from Friday. So to undo over 2, I multiply both sides by 2. I got 16 equals 2. Pretty straightforward. Is it making sense? So if I look at letter C, what's going to be my first step here? Here's my variable x. What do I want to do first? What goes first? Go ahead, Jacob. Yeah, I want to get rid of that plus 2, so I'm going to minus 2 from both sides. Negative 2 minus 2 is negative 4. And then what? How do I get rid of that 1/3? Yeah, so I'm going to divide by 1/3, which is the same thing as multiplying both sides by the reciprocal, aka 3 over 1. So x here is a negative 12. Questions on that? Okay, I'm going to make things a little bit trickier. Look at letter D. What's going to be my first step in letter D? We're thinking backwards GEMDAS. What are we thinking? First step. Jaden. Okay, I was hoping you were going to make this mistake. Jade, do you know? Why are we multiplying by -5 first instead of subtracting the 4, which I think a lot of us probably thought too? Why does it make sense to multiply by the -5 first? Do we remember where this comes in GEMDAS? What letter is that? This fraction bar is what? Do you know, Cade? Is that a hand or no? Do you remember what letter the fraction bar is? It's division, but also what? Yeah, it's grouping. Fraction bars we treat as grouping symbols. So before we can treat that as division, we have to keep in mind that that's a grouping symbol, which means if I have a fraction like this, the stuff in the top of my fraction is like trapped. It's stuck. Put some parentheses around them. We cannot touch anything in the top of our fraction until we get rid of that denominator. So then just like Jade said, we're going to go ahead and multiply by that -5 to get rid of it, which gives me 10 equals, and now the stuff that's in the top of that fraction is free, and we can move it around however we want. That's a really tricky one. I would maybe put a star here to remind us that this is one that's going to come up and trick us. And then we can proceed, just like Jaden was saying, we're going to go ahead and subtract that 4 to get 6 equals x. Kind of a weird one here. Any questions on that? Okay, the next one, also a little bit weird. Multiple steps here. Take a look at E. What do we think is going to have to happen first? James, yes. Close. There's something else that's further away from the x that we can do first. You are right, this is trapped. But what can we do first, Monica? We can -5 first. So yes, the 2x in the top there is trapped. Can't do anything with it. But that +5 there, I can move that for sure. This is -17 here. And then now that everything else is moved away, I can start dealing with this fraction. Now I'm going to multiply by my -3. So the 2x is now unstuck. -17 times -3 is a +51. And I can finish it off by dividing everything by 2. A lot of steps here. That was 3 steps we just did. Any questions on that? This is another one that maybe is important that might come back up, so maybe give it a star. Okay. Letter F. What's my first step in letter F? Yeah. Subtract 8. Why is it subtract 8 when I see a subtraction right here, so I think I must do the opposite? Why is it -8? Because 5x is negative. 5x is the thing that is negative. Remember that negative goes to what's on the right of it. So 8 actually has an invisible plus sign next to it. So if I was trying to move that 8, I would have to do the opposite, which is minus. Do not get tricked on something like this. Also maybe a star problem. I'm going to finish that off by dividing by -5 to get x equals -3. Questions on these 3 on the bottom here. These 3 on the bottom are like set up to trick you, so do not get tricked. Okay, next page. I'm going to give you a couple minutes. Try A, B, and C, and then if you feel good about it, I'll let you draw on the surface. It's fun, I promise. Give it a try. Check with your neighbors. If you feel good, raise your hand. I'll bring it to you. Do you need a new notes packet? Do you have yours? I can get you a new one. What's up? Got one?
What do we do when the variable's negative?
What's the number in front of there?
1.
Okay, so how do you get rid of -1 in the front of a t? There you go. Anybody got letter A they feel like they can solve? I'll bring it to the front here. Layla, you can give it a try. You got the next one? Oh, where'd it go? Is that the one I want? Where the heck did I just go? Am I lost? Oh, right here. Sorry. Go for it. Perfect. Anybody got letter B? Let me double check. Yeah, sounds great. All right, cool. Oh, see? I'm not the only one here.
I'm trying to rest my hand on it.
Yeah, but it's a little bit tricky. Lovely. Who's got C? Anybody feeling brave? Nobody?
I can do it. It's great.
Yeah, but you already did one.
No one else is
I got one. Don't worry. Man, we're gonna have to start
Is this
popcorn.
right?
Yeah. Perfect. All right, any questions on these three? We're making sure we're not getting tricked by these silly fractions. We're treating those as parentheses up at the top. Jaden, question? Sure. I'm fine with that. Other questions? All right, let's talk about this word problem. All right, Jimmy's buying V-Bucks. I don't know, he's going crazy. He's spending half of his allowance on V-Bucks. To earn money, his parents paid him $10 to wash the car. He ended the week with a total of $40. How much is Jimmy's allowance? Number one thing we need to do, always, is define our variable. What don't we know in this scenario? Jaden.
How much is allowance?
Yeah, so let's make it a variable. I'm going to call it A for allowance. And then I'm going to start breaking this problem down. When I start looking at word problems, the first thing I'm looking for is a total. What's our total in this problem? $40. We know he ends with $40. That's right here. That word total. What else do we know in this scenario? Autumn. Perfect. If he gets an extra $10, what math operation am I going to use there? Yeah, I'm going to add 10 to whatever he's got. What else do I know? James? He already spent half of his allowance buying V-Bucks. So how would I represent 1/2 of his allowance? How would I write that? Autumn? Yeah, 1/2 A. Oops. Perfect. So that's our equation. $40 at the end of the week is equal to 1/2 of his allowance plus the $10 that his parents gave him for washing the car. So now we can solve this, right? I'm going to draw my line down the middle. I'm going to start by subtracting 10 from both sides. And then I got 1/2 times A. To undo that, I'm going to divide by 1/2, aka multiply by the reciprocal, which is 2/1. So before he started spending all that hard-earned money on V-Bucks, he started with his $60 allowance. Any questions on that?